In this section, we're going to look at difference of perfect squares and perfect square trinomials. We are going to explore what is unique about factoring difference of squares binomials. The difference of perfect square binomials will be recognizable to you, first because the problems will only involve two terms, which are binomials. There will be a subtraction sign in the middle. And lastly, the two terms that are in the problem will be perfect squares, meaning that you can take the square root of each term. Let's use this as an example, a squared minus b squared, to demonstrate how you would factor a binomial with the difference of perfect squares. When you recognize that two terms are perfect squares and there is a subtraction sign in the middle, we're going to start by writing our solution as the product of two binomials. We take the square root of the first term, which would be a, and the square root of the second term, which would be b, and in between one parenthesis we write a plus sign, and the second parenthesis we write a minus sign. Now it's really important that you are aware of your problem and whether or not there is a subtraction sign in between your perfect squares. The reason why is because if we go to check our solution by FOILing, we'll get a squared minus ab plus ab minus b squared. So what you'll notice is happening, if I combine my like terms together, positive ab and negative ab cancel out. And what allowed this to happen was the fact that we use a plus and a minus sign in between our solution, allowing us to get a squared minus b squared back again as a solution. Let's look at some examples. X squared minus 81 is our first problem. We're going to write this as the product of two binomials. First, we'll take the square root of x squared, which is x, followed by the square root of 81, which is 9, and we'll write a plus sign and a minus sign in between. Let's check our work. By FOILing, I'll get x squared minus 9x plus 9x minus 81. And if I simplify, my middle terms will cancel out. X squared minus 81 was the original problem that I began with. So I know that x plus 9 times x minus 9 is my solution. Let's quickly look at a counter example to this problem. In my counter example, instead of my problem beginning with x squared minus 81, I'm going to change it to x squared plus 81. If I were to factor this, I'll take the square root of my first term and the square root of my second term, as I've done before. Now when it comes to the signs, if I attempt to put a plus and minus sign in between here, as we did in our last problem, we know that if we check our work by FOILing, we already know from the example we just did that we'll get x squared minus 81. X squared minus 81 does not match x squared plus 81. So we know that using a plus and a minus sign in between here is not going to work. So let's next try some different signs. Let's go with two plus signs in between. This time, if I check my work through FOILing, I'll get x squared plus 9x plus 9x plus 81. But you'll notice a plus 9x and a plus 9x is going to give me an 18x in my center. And now my solution when I FOILed does not match my original problem. So we know that the two plus signs are not going to work. One more option that we have is to try 2 minus signs in between. So let me throw 2 minus signs in between here. This time when I check my work, I'll get x squared minus 9x plus 81. And this time I get negative 18x in the middle, which still does not match my original problem. So this goes to show the importance of always having a subtraction sign in the middle of your problem in order to indicate that you are solving by the difference of perfect squares. When there's a plus sign in the middle, this problem does not factor. Let's look at our next example. 25x squared minus 100. We're going to write this as the product of two binomials. First, we'll take the square root of my first term, which gives me 5x, followed by the square root of my second term, which gives me 10, and we'll place a plus and a minus sign in between. So my solution is 5x plus 10 times 5x minus 10. In my last problem, 16x to the fourth minus 49y squared. We'll take the square root of 16x to the fourth, which is 4x to the second, and then we'll take the square root of 49y squared, which is a 7y, with a plus and minus sign in the middle. So my solution is 4x squared plus 7y times 4x squared minus 7y. The final examples that we'll look at for today are the method of factoring perfect square trinomials. This will be recognizable to you because you will have a trinomial with 3 terms. There will be plus signs in between all of your terms. And lastly, the first term, including the variable, and the last term will be perfect squares, so we'll be able to take their square root. Let's look at how we factor this. We want to write this again as the product of two binomials. I'm going to take the square root of my first term, which is 3x, and the square root of my second term, which is a 4. This problem had 2 plus signs in the trinomial, which means my answer will have 2 plus signs in between. If we were to check our work, we're going to FOIL to get 9x squared plus 12x plus 12x plus 16. And combining like terms together is when we will see our middle term from the problem, 24x. And we know that 9x squared plus 24x plus 16 matches our original equation. So our solution of 3x plus 4 times 3x plus 4 is correct. A second way that we can write this is 3x plus 4, the quantity squared. Another way that you can check yourself, there is a trick to this problem. So here's a second way for you to check your work. We'll call this check number 2. You're going to take the exponent, the square, and your first term, 3x. 3x to the second power is 9x squared. 4 to the second power is 16, a positive 16. In between, we're going to take 3x times 2, which is 6x, and multiply that by 4, which will give me the inside term of 24x. So that's a second trick for checking your work on a perfect square trinomial. Here's one more perfect square trinomial for you. 100x squared plus 260x plus 169. Notice that we have two plus signs in our trinomial, as well as the first and the last term, which are perfect squares. So when I factor, the square root of 100x squared is 10x. The square root of 169 is 13. Both will have plus signs in between since our original problem had plus signs. And you can finish this off by rewriting your answer as 10x plus 13, the quantity squared. You may check your work either by foiling or using the second check method that I showed you in the previous example.